All right, so chapter 6 is on solving systems of equations by graphing, substitution, elimination, and then solving systems of inequalities. We're going to start today with solving systems of equations by graphing. So go ahead and pre-rate yourself on there. The goal is I can solve a system of equations by graphing. All right, so what is a system? A system of equations consists of two or more equations with two or more variables. So if you look at this right here, this is a system. It's two equations, and there's two variables, x and y. Okay, so here's an intro. It says, determine whether the point is a solution to the system. So we're going to start with 2, 5. So I want to know if it's a solution to the system on the far right here. Okay, so what I'm going to do is I'm going to plug in 2 for x and 5 for y into both equations, and I'm going to see if it's true in both. If it's true in both, then it's a solution to the system. If it's not true in both, then it's not a solution. So I'm going to plug in x and y. So I have 5 equals 2 times 2 plus 1. So is 5 equal to that? Yes, that's 5 equals 5. So far, so good. Now I'm going to plug it into the second equation. So I have 5 equals negative, and then the x value, which is 2, plus 4. So is 5 equal to negative 2 plus 4? No, it's not. So no, this is not a solution to the system. Let's try 1, 3. Y equals, not y equals, my bad. This is x, this is y. So 3 equals 2 times 1 plus 1. That's 3 equals 3, true. Now we're going to plug in 3 and 1 into the second equation. 3 equals negative 1 plus 4. That's also true. So since they're both true, this is the solution to the system. Now, how do we find that 1, 3? That's the question here. So it says, what did we find? A solution to the system is a point that makes both equations true. Okay, so it's a point that's on both lines. All right, so now let's go ahead and solve some systems by graphing. So notice we have 3 examples here that we're going to start with. So example 1 says graph each equation on the coordinate plane. So that's what we're going to start by doing. Start by graphing this line right here. So that's y equals 2x plus 1. I have a y-intercept of 1 and a slope of 2. So over 2 up 1, over 2 up 1, over 2 up 1. Down 2 left 1, down 2 left 1, down 2 left 1, down 2 left 1. Now, it's super important that you put all of the points on the line because your solution is one of the points on this line. And if you don't graph them all, your line might be crooked and you might say the wrong line. Okay, so the more, the merrier. All right, now I'm going to go ahead and graph my second line, y equals negative x plus 4. I have a y-intercept of 4 and a slope of negative 1. So I'm going to go down 1, right 1, down 1, right 1. Once again, I like to get in the habit of making all of my points. I know I can see my solution already, but guess what? I have to get into a habit, so I'm not going to quit on the first problem. Okay, so there's my 2 lines. Where do the 2 lines intersect? Okay, where do the 2 lines intersect? They intersect at this point right here. What is that point? That point is 1, 3. So how many solutions does this system have? It has one solution, and the solution, the only solution, is 1, 3. So notice we just actually did this by graphing and showed that it's 1, 3. Okay? Now, if you look at the point 2, 5 from over here, you'll see that 2, 5 is on the purple line, but it's not on the red line. That's why it's not the solution to the system, because it's not a point on both lines. Okay, let's look at our next one here. Graph each equation on the coordinate plane below, and then answer the following questions. So we will start with y equals negative 3x plus 4. So I'm going to start with my y-intercept of 4 and my slope of negative 3. So I'm going to go down 3, right 1. Down 3, right 1. Down 3, right 1. I could also go up 3, left 1. Then I'm going to connect these points that I made with a straight line. And there's my first line. All right, now I'm ready to graph the second line. Now, this is in standard form. So remember, when it's in standard form, what we're going to do is we're going to plug in 0 for y and see what point we get. So if I do that, I get 3x equals 4. Divide by 3 and I get 4/3. I don't want to graph the point 4/3 0. I'm not going to have it accurate enough. So if that ever happens, all you have to do is get it in slope-intercept form. To get it in slope-intercept form, it has to be solved for y. So I'm going to subtract 3x from both sides. So I have y equals negative 3x plus 4. Now I'm going to go ahead and graph that line. What you should notice is that it's the exact same line. So it is the exact same line. I'm going to, if it was pencil, you wouldn't have to graph it over it, but these are our notes. I want to show that it's the exact same line. What do you notice? They are the same line. Oops, I almost put same line. Same line. How many solutions does this have? So this blue line that I drew, which you could hardly see, I wonder if I could like pick it up and move it. No, what if I went like this? Yeah, you can. Oh, but my blue line disappeared when I drew over it. Because they're so on top of each other. That's why. But my blue line and my red line, if I ask you where they intersect everywhere. So if I ask you what's the solution, there are tons of solutions. It's every point on the line. So how many solutions does this have? This has infinitely many solutions. And I spelled infinitely wrong. It's infinitely. Wow, I can't spell today. Infinitely. There we go. Wow. Infinitely. There we go. Many solutions. So when it intersects that many times, there are infinitely many solutions. Well, when I say that many, an infinite amount of times. If I asked you what is the solution to the system, you could say infinitely many solutions, or you could say all points on the line. I prefer infinitely many solutions. Okay, next one. Graph each line. So I'm going to graph this line first. Y equals 1/2 x minus 3. So y-intercept of negative 3. I should do this in blue. Y-intercept of negative 3 and a slope of 1/2. Up 1, over 2. Up 1, over 2. Up 1, over 2. Down 1, left 2. Down 1, left 2. Down 1, left 2. Go ahead and connect those points to form your straight line. There we are. And now I'm going to graph the next line. The next line is y equals 1/2 x plus 5. All right, y-intercept of 5, slope of 1/2. Up 1, over 2. Up 1, over 2. Down 1, left 2. Down 1, left 2. Down 1, left 2. All right, now if I asked you where do these lines intersect, you should say, well, they don't, right? What's true about these lines? These lines do not intersect. What's that called when things don't intersect? It means they're parallel. The lines are parallel, meaning they don't intersect. So if I ask you how many solutions does it have, the solution is the intersection. They don't intersect, so there is no solution. There are no solutions to this. Now, I want you to realize what in my two equations tells me that my lines are parallel. My slopes. So if I would have looked at my slopes before, I could have said, hey, those slopes are the same, but the y-intercepts are different. So it's not the exact same line like these two, right? Same line would give me infinitely many solutions. Same slope but different y-intercept is going to give me no solutions. So, sample of each. How many solutions is this going to give me? This right here, there's going to be one solution. This is going to be infinitely many solutions because it intersects infinitely many times. And this does not intersect at all, so this is no solution. Okay, so now we just have 4 examples of graphing, and they're just practice. Okay, so we're going to try each one. We'll start with this one right here, and we're going to graph y equals x plus 2. So I have a y-intercept of 2 and a slope of 1. Go ahead and connect your points. Okay. All right, now I'm going to graph my second line. Here's my second line. Oops. Here's my second line. Y equals negative x. So please realize this is y equals negative x plus 0. So my y-intercept is 0, and my slope is negative 1. So down 1, right 1. Down 1, right 1. Keep going. And I can also go up 1, left 1. And you can see that I hit the intersection there. I'm going to connect these points with a straight line. And the intersection is my solution. So first off, how many solutions are there? There's 1 solution. And what is that solution? It's this point right here. That point is negative 1, 1. All right, let's try another one. So this next one here is in point slope form. I'm sorry, no, it's not. It's in standard form. So once again, the easiest way to graph this is to try to get the x-intercept and the y-intercept. Oops, the y-intercept. So that's what I'm going to do. I'm going to plug in 0 for for y, and see what I get for x. If I do that, I get x minus 2 times 0, which is just 0, equals 4. So I have the point 4, 0. Now I'm going to plug in 0 for x and see what I get for y. I get negative 2y equals 4. So y equals negative 2. So now I have those 2 points, 4, 0, and 0, negative 2. Now, what I just did right there, which I shouldn't have done by myself here, I looked at what the slope was. So if I just connect these 2 points, which I need to connect all of them, so that's not going to be good, you can see that you would also go through this point right here, and you can see that the slope is up 2 over 1. So I'm going to make sure I put every point on the line by going up 2 over 1, because one of those is the solution. I'm just not sure which one it is yet. All right, now I can connect all my points. There we go, and there's my line. All right, now I'm going to graph the second line. Y equals negative 1/3 x plus 3, so y-intercept of 3 and a slope of negative 1/3. So I'm going to go down 1, right 3. Down 1, right 3. There's my intersection, but I'm still going to graph the rest of my line by going up 1 and left 3. And there's my second line. So how many solutions does this have? This has 1 solution, and that 1 solution is this point of intersection, which is the point 6, 1. All right, let's try the next one here. I have my first line, which is in standard form. I'm going to find the x-intercept and the y-intercept. I'm going to plug in 0 for y and see what I get for x. This will disappear. I have 3x equals 6. So x equals 2. 2, 0. Now I'm going to find my y-intercept by plugging in 0 for x. This goes away. I have 3y equals 6. So y equals 2. So now I can graph those 2 points, 2, 0, 0, 2. If I connect those 2, I can see that it'll also go through this point. So you can see my slope is negative 1. So I'm going to keep continuing that pattern. And then I'm going to connect all of the points on the line. Ooh, that was a little crooked. All right, now I'm going to graph my other line. So my other line, I'm going to do it the same way since it's in standard form. I'm going to find my x-intercept. I'm going to find my y-intercept. So I'll plug in 0 for y to see what I get for x. I get 4x equals negative 16. X equals negative 4. Negative 4, 0. Now I'm going to plug in 0 for x to see what I get for y. I get 4y equals negative 16. So y equals negative 4. 0, negative 4. So now I'm going to graph that line. Negative 4, 0. 0, negative 4. So I can connect just those 2 points for now just to see what other points it goes through. A little crooked. It goes through this point, and this point. So I can see that the slope is -1 also. So now I can connect all the points on the line. And if I look to see where these two lines intersect, they never do. So there are 0 solutions, and there is no solution. All right, last one. This is in standard form. So I'm going to try to get my x-intercept and my y-intercept. I'm going to plug in 0 for y to see what I get for x. I have 2x is equal to -7, and I notice that I'm going to get a decimal again. So I don't want that to happen because it's not going to be accurate when I graph my line. So instead, I'm going to solve this equation for y. So I'll subtract 2x from both sides. I have -y is equal to -2x minus 7. And now I still need to get y by itself. Please realize this is a -1 in front. So I'm going to divide by -1. And then remember, you have to divide everything by -1. So this becomes y equals positive 2x plus 7. Now I'm going to graph that. Y-intercept is 7 and a slope of 2. I want to go up 2 over 1, but realize that's not on my graph paper. So I'm going to have to go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, and continue that. Then I can see that. There's my line. And now I'm going to graph my other line. My other line is the line y equals x plus 4. So I have a y-intercept of 4 and a slope of 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. I also have to go down 1, left 1, down 1, left 1, down 1, left 1, and keep going. Connect those points. And I can see that these two lines intersect once. Where do they intersect? They intersect at this point right here. And that point is -3, +1, and that's my solution.